Welcome guys to the chapter 5.2 homework. Alrighty, let's begin. Question 1. Find the domain of the following rational function. Okay, so let's see. The equation says y equals 17x divided by x plus 3. Alrighty, so let's recall, in order to find the domain, we have to first find out what x cannot be. So we always look at the denominator for rational functions. You guys remember in class we talked about it. The denominator cannot equal to 0. So whatever makes that denominator 0 is not in the domain. We'll call that a restriction. So what would x have to be for this x plus 3 to become 0? You guys are correct, it's negative 3. So that means that's the one number x cannot be. And then there you go. That's going to be the solution. So let's go ahead and put the answer here. X cannot equal to. The not equal to is found here in this little table. Not equal to negative 3. Alright, fantastic. Next question. So let's clear the drawing board. So we're asked to do the same thing. Again, remember guys, the numerator is not important when we're looking for the domain restriction. The only thing that matters is the denominator, okay? So let's write this out. Alrighty, so here's my equation. And remember the idea. The idea is that this cannot equal to 0, the denominator. So we got to factor that denominator. It's a tougher one to factor, I see. But it's not too bad. Remember, I'm going to show you a shortcut how to factor it. I'm going to write the equation here. And I'm going to factor it down here, okay? So I remember I explained to you guys in class, we're going to temporarily borrow this 6 and multiply that into the negative 7. So when I do that, the 6 is no longer there. It's kind of disappears. But remember that we multiplied it. We multiply the 6 into that negative 7, so now it's negative 42. Don't forget we did that. Next, we're going to go ahead and we're going to look for two numbers that multiply to negative 42 and add up to negative 41, right? These are the two different conditions. So let's see, 42 times 1, right? So negative 42 times positive 1 is negative 42. And if you add them up, you get obviously negative 41. So we found it. Now here's the only thing you have to remember. The negative, so negative 42, it's not technically done yet. Actually, I can do this technically. And then x plus 1. Now, we remember how we we multiplied by 6 earlier. Remember this step? We're now going to divide these two answers by 6. So that's how you remove or undo the original 6 multiplication by dividing. And we divide the two factors that we found because we were able to multiply. So let's simplify this. What is that? So 42 divided by 6 is 7, right? And then, so that's going to say x minus 7. Now you can't simplify the second one. Now if we were only looking for solutions, we could technically forget about what I'm about to show you. In fact, I'll do this. I'll leave it like this for now. And I can then find the zeros for these two, and I'm done. I don't have to completely factor it properly. I'm going to factor it properly because this is technically incorrect. You're not supposed to have a fraction here. So what you do in the cases when you can't simplify this away, like we did, how we were able to simplify that to a 7, but the 1 over 6 couldn't be simplified. We're going to take that 6 and move it up next to the x. So it ends up looking like this. X minus 7, and then 6x plus 1. And then that's the correct factored form of the equation. Now, could I have left it like this right here? Yes, you could have. That's not a problem. So I could have, if I felt like it, I could have just used these factors and realized, okay, the two numbers x cannot equal to are, for this factor is 7, and for this one is negative 1 over 6. Those are the two numbers x cannot equal to. So those are my answers. Or you could have, once you factored it correctly, you would have done the same thing. 7 for this one. And then you think, okay, what about that one? Well, 6x plus 1 equals 0. You solve for x. You're going to get 6x equals negative 1. Divide both sides by 6. X equals negative 1 over 6. Or technically not equal to. So we're going to get the same answer either way. So our two answers are 7 and negative 1 over 6. Those are the two numbers you cannot use. What about the numerator? Irrelevant. Doesn't matter. So we're just going to go ahead and just put that solution. Let me get rid of the draw. it's a, and we're going to say it's x is not equal to, it's hard to see, is it this one? Yeah, not equal to -7, no, +7, and -1/6. Let's see if that works. Excellent. Let me erase all this because it's hard to see what I'm doing. Clear. All right. Hopefully that made sense, guys. If you wanted to, you can also use quadratic formula for the denominator to solve for those two zeros that x cannot equal to. It's up to you. Okay. All right. Next one. Same thing again. We're going to go ahead and, in fact, actually, we don't have to factor if we don't want to, but might as well, so we can get used to factoring. Factoring is a very important skill. The numerator I'm not even going to worry about. I'm just going to leave it blank. It's the denominator that I care about, remember? When we're looking for the domain. So to factor that denominator, this is the difference of two squares. So we have x plus 5, x minus 5. Now could you have also have left it like that and solve for x? Yes, you could have done it like this. So if you so chose, you could have said let x squared minus 25 equals 0, and you would have solved for x, and you would have gotten -5 and +5, right? Or plus or minus 5. Well, the same thing here, -5, +5. You're going to get the same two answers, okay, guys? So my domain is, oh, I got to get this out. Domain is x cannot equal to, not equal to, -5, +5. Alrighty. Next question. Let's clear this up. This has quite a few parts. Okay, so we're going to do step by step all the parts and see if this makes any sense. All right. Step 1, the domain. Now we have to look at the picture for the domain. It doesn't have an equation. So let's look at this picture and let's pay attention. Remember, domain is what x value can you not plug in. Now, there's only two ways visually that you cannot plug it in. If you see any holes in the graph, like open circles, those are x values you can't plug in. And if you see any vertical asymptotes. So in this particular problem, we see a vertical asymptote right there. This means that for this x value, there cannot be a solution. So that's that's +1. So x cannot equal to +1. That's where the vertical asymptote exists. So x cannot equal to +1. All right. Next, what's the range? Now the range is just like the domain. We're looking for restrictions. What y value can you not use? Now, I know you're thinking, I know I mentioned before, horizontal asymptotes can be intersected with, or intercepted, excuse me, with, and that's true. But if you don't see the intersection, I'm not even sure if it's the right word, interception, if you can't see it, then that you can assume it doesn't intercept anywhere, okay? So, the intersection does not exist here. And we also notice there's no points here on this line. That means that the y value cannot equal to whatever this y value is, which is -4. So that's my range restriction. Okay? My range restriction is y cannot equal to -4. That would be the horizontal asymptote. All right. X-intercepts. Are there any x-intercepts? Let's look at the picture. Yeah, there is just one right there, the origin. So 0, 0. So x-intercepts when x is 0. And the y-intercept is the same. Whenever you have the origin intercepting, that's both y and x intercept at the same time. So it's just 0, 0. Alrighty. Any horizontal asymptote? Yes, the one we found earlier, the range restriction, at -4. We had a horizontal asymptote. Alrighty. Any vertical asymptotes? Well, yes, actually, at 1, just like we said earlier. The restriction is also there. So when x is 1. And that's it. Alright, that's not bad. Pretty simple. Oh, wait, there's more. Okay, so the horizontal line is horizontal. It's not oblique. Oblique means it would be slanted instead of horizontal. So that means it's not oblique. You can't have two. You can't have horizontal and oblique for polynomials, okay? I'm sorry, for rational polynomials. It has to be either or. So it's either horizontal or it's oblique. Since we already see it's horizontal, then it's not oblique. Alrighty, next question. So I know you're thinking here, oh, what the, but this is not too bad. You guys remember from chapter 3, the transformation. So this equation is going to be that reciprocal function we learned in chapter 3.4. So if I were to take that equation and then I decided to add 7, okay, that's what it says, right? It says add 7. That means the entire graph will go up, down, left to right. You guys remember? Hope you guys are saying up 7. So now it looks something like this. That's 7. You guys understand? So I hope that you guys said that. So let's see. A says it's going to the right. That doesn't make sense. B is going down. No. C is going up. So yes, C is the correct answer. We're going to choose C and move on to number 6. Let me clear this out. Oh wait, no, we're still here. Okay, so domain. So now we have the picture. Well, actually, we don't have to do the picture. We can always look at the function. The one number you can't plug in is 0, because 1 divided by 0 is undefined. So we're going to say the answer is B. Let me do this. All right, let's see the next part. The range. So let's look at this picture now. It's easier to look at the picture. What's the one number that you can't, you don't see a y value for? And I think you're starting to notice I'm identifying it. It's that horizontal asymptote. It doesn't actually intersect. It looks like it will, but it never does. It gets closer and closer and closer. So it will never equal to, I believe it's 7. Now I'll give you guys a hint. Whenever you have an equation in this format, okay? Whenever it's in this format, y equals to some rational function, doesn't matter what it is, blah, 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 plus a number, plus 7, plus some other constant. We'll put plus c. This is going to be both my restriction for my range and my horizontal asymptote. It's going to be both horizontal asymptote. And it also happens to be my range restriction, okay? So just keep that in mind. So the range is going to be whatever that number is, in this case, 7. It cannot equal to 7. All right, let me do this. Alrighty, good job. Vertical asymptotes, well, yes, because we can't plug in 0, then that's the vertical asymptote. It has 1, it is x equal 0. Okay, here we go. Horizontal, yes, there's 1. It's going to be y equals 7, right? So y equals 7. Don't just put numbers, guys. Oh, didn't type. Hang on. Y equals 7. Make sure you put the entire equation for the line, y equals or x equals, okay? There's no oblique. Remember, it's horizontal already, so it can't be both horizontal and oblique, so we're going to put no oblique. Excellent. Next question. Let's see me clear this up. All right, let's see. The following function. Okay, so let me draw. Here's my equation. X plus 9 squared. Now I hope you guys remember 1 over x squared, this equation, looks like this. If you didn't, well, I'll remind you. 1 over x looks like this. Different infinities for the vertical asymptote. Remember, this is the vertical asymptote. So this is going down and this side is going up, different infinities, because the multiplicity of that factor is 1. But when the multiplicity is 2, they share the same infinity. And it's going to make sense because this fraction is always positive. So the entire graph should be above this x-axis, okay? So I'm going to clear all this out and start over. Okay, so for this equation, it's going to obviously look something like this, but this plus 9 makes it go up, down, left to right. Correct, it goes left. So, because when it's inside happening to the x, it goes left to right, and it's always opposite. So if it's plus 9, it's going left. A is going to the right, B is going left. Looks like B is the answer. C is going down, D is going up. So the answer is B. So let's go ahead and select B and see what happens. Nice work. Next step. Let's clear this out. The domain. So again, what's the one number you cannot plug in to this function? Okay, so 1 over x plus 9 squared. The denominator can never be 0, so what's the one number you can't use? You're correct. You can't use negative 9. If you try negative 9, it'll be 1 divided by 0, and that's not possible. So we're going to go ahead and put x cannot equal to negative 9. Alrighty. Next question. The range. So we're going to look at this image. It's much easier with the picture. Is there so the graph is always positive. You notice that? It's never negative. It's always above the x-axis. That means that the graph is always greater than what number? What's the smallest number this range has? If you say 0, you're correct. It's always greater than 0. So we're going to say it's greater than 0. This is where it's very nice to have a graph to see the range, okay? Check answer. Excellent. Vertical asymptotes. Well, we talked about this. Vertical asymptote is going to be that restriction, right? And I believe it was negative 9. Yeah, there it is, negative 9. So it's going to be x equals to negative 9. Alrighty. Let's see the next one. Horizontal asymptote. Yes, we mentioned that as well. The denominator, this is case 1, is a bigger degree than the numerator, so it's automatically y equals 0. This is the easy case. So y equals 0. Refer to the 5.2 lecture if you guys need any more clarification. That means it's no oblique because you can't have both. That one line is horizontal. It's not oblique. So we're gonna. That's it. All right. So let me clear the drawing board. All right. What's this one asking for? All right. It's asking us to do the same thing, but it's a little different. So it's gonna say, I like to write it like this. I like to put the fraction first because it's very easy for me to read it this way. And that's a plus 2, right? So I'm going to put positive 2. So forget the 4 for a moment. The 4 is important because it's going to obviously stretch it vertically, but we're not going to worry about the 4. We're going to worry about this plus 1 that's happening inside the x and this positive 2 that's happening outside. What does the plus 1 make us do when it's inside with the x? If you said go left 1, you're correct. Okay? What about this plus 2 that's outside? If you said it goes up 2, then you're also correct. So the graph would ordinarily look like this, right? Because it's 1 over x squared. But it's going to go left 1 and up 2. So it's going to go a little bit to left and up. So let's see. Ooh, boy, this is impossible. I got to click each one. There's no way I can tell. They're so small. So I'll click this one. See, now, remember, this blue dotted blue line should started at 0, 0. And then it went down and right. That's not correct, so it's not it. Let's look at this one. Okay, this went left 1 and up 2. The answer is B. You can see how it definitely went left and up. So I know the answer is B, but I'm going to just show you C and D, why those aren't wrong. This one's going to the right and up. This is a common mistake. People will forget this is the opposite direction. And finally, D, it's going left and down. So it did go left correctly, but instead of up, it went down. So that's incorrect. So we're going to say the answer is B. Next, let's clear the drawing board. Domain. So it's easy to figure it out. The domain would be whatever would make that denominator 0. So in this case, what's the one number that would make x plus 1 0? And you guys guessed it, negative 1. X cannot equal to negative 1. So we're going to go ahead and put that x cannot equal to. It's going to type negative 1. Oops. Alrighty. Fantastic. The range. So remember, guys, I mentioned to you the range restriction is going to be in front of you if it's in this form. Okay? The range restriction and horizontal asymptote is going to be that number. That's like a shortcut. So this would be my range restriction. Or it's also, this is my range, but it's also my horizontal asymptote. Y equals to 2. So we have both horizontal and range all at once. So let's look at the picture and confirm it. What's the one number that this can't be? Well, actually, I take it back. I said we're equal to 2, didn't I? That is correct for the horizontal, but what's incorrect is that this is greater than. So I'm glad I saw that picture, guys. It's greater than 2, not just not equal to. It's greater than 2. And the reason why, and I forgot, is that this is going to both in the same direction of the infinities. It looks like this, right? If it were to look like this, then it would be correct to say not equal to 2, if that were 2. But because they're both going the same direction, there's no number underneath that, so it starts from 2 and up. You guys see that? So that was, I'm sorry, that was my mistake. I did it a little fast. Thank goodness I checked with the picture. So let's go ahead and click A and put 2. And let's check our answer. Well done. Alrighty. Vertical asymptotes, we talked about this. It's the same as the domain restriction. So there is one vertical asymptote, and the equation is x equals -1. And horizontal, we talked about that. That is y equals 2. Oh, I didn't type. Y equals 2. And then that line is not horizontal and oblique. It can be horizontal or oblique. So since it's horizontal, the answer is it's not oblique. Excellent. We're going to clear the drawing board. Alrighty, we're almost done. So this one, it's asking us to determine the asymptotes. So let's see. The asymptotes would be whatever makes that denominator 0 and cannot be canceled out of the numerator. So remember guys, I like to always do this. Domain restriction, x cannot equal to -11. Can I cancel anything out of this? Clearly no. So this also happens to be my vertical asymptote. Alright, so it has one vertical asymptote. X equals -11. Next, horizontal. So we have to look at this form and ask yourself, what's the degree of the numerator? Well, it's 1. The degree of the denominator is also 1. When they're the same degree, you just take the coefficients. Remember that, guys? You just take that number. So it's going to be y equals 9 over 1, which is just 9, right? That's my horizontal asymptote. It's no longer, that's not oblique, by the way. It's a horizontal line, so it doesn't have an oblique. So it has 1. Let me get rid of the drawing. It has 1 horizontal asymptote. Y equals 9. Alrighty. Therefore, it's not oblique. Alrighty. Let's clear the drawing board. Okay, so vertical asymptotes, again, we're going to make the denominator, so x cubed, let me change this color, x cubed over x to the 4th minus 81, y equals, so we have to think of what, we can either factor the denominator, which I'm going to do, or we can also just solve it like this, guys, and solve for x that way. But I'm going to go ahead and factor. X to the 4th minus 81 is x squared plus 9 and x squared minus 9. And then we can factor one more time. Not this. This can't be factored. In fact, this has no solutions. We're going to ignore that. But this can be factored. So it's going to be, so technically this is still there. Technically, I'm not going to not write it. But it's not important to us. Okay. So this is no solution. Again, x squared plus 9. Like I mentioned in the lecture, it has no way that's going to be a 0. It's always positive. But these two have solutions of 0, right? So x cannot equal to -3 and +3. Those are the two numbers x cannot be. Now, the question is, in this giant crazy equation I just figured out, can I cancel anything out? The answer is no. So those two domain restrictions are also, so this is my domain, these are also vertical asymptotes. X equals to -3 and 3. So there are two, that'd be answer B, right? There are two vertical asymptotes. The most left one is x equals -3, and the rightmost one to the right, will be x equals 3. All right. Remember, guys, the multiplicity of each is 1. In case they ask, I'm not sure if they ask for this, but in case they ask for like, oh, what direction is the infinities? They're going to go in opposite directions for that reason, okay? does it say here? What's the okay, so does it have horizontal asymptote? Let's look at the original equation. The answer is yes. Because the denominator is bigger than the numerator, automatically the horizontal asymptote is y equals 0. Again, refer to the lecture if you want a better explanation. Alrighty. Let me, I'll leave this here. So if it's oblique, sorry, if it's horizontal, it can't be oblique. So it's no for oblique. You can't both answer. It's either one is yes, the other one's no. The other one is no, and the first one is yes, or they're both no's, right? So, but we don't have that case here. Let me clear the drawing board. All right, this one. I believe I took this question out. I'm not sure why it's still here, but let's go ahead and do it. In physics, you have this, equation they gave us before. Us, we see this cool equation. It's saying here. So what is G? G says in physics is that the gravity G at the height h meters above the sea level is given in the formula. So the gravity is equal to, and they give you this giant number, so it's in scientific notation, divided by, there's the rational function, 6.374 times 10 to the 6th power plus h, and all of that squared. And that big number, 6.374, is the radius of the Earth. Okay. Answer parts A through C. So A certain building is 292 meters tall. What is the acceleration due to gravity at the top of the building? Alrighty. So all you gotta do is just plug it in. Really? That's all you gotta do. So 3.99 times 10 to the 14th over 6.374 times, this is the times, 10 to the 6th plus 292 squared. That's all you have to do. Definitely have to use a calculator, guys. I'm going to go ahead and use my calculator. So let's see, I'm going to put 3.99 times 10 to the power of 14. And the top and bottom is going to be 6.374 times 10 to the 6th power plus 292 on all of that gets squared. And I got, how many decimals? Says 4 decimals. Wow, 4. I got 9.8199. So let's see if I got this right. Hope I typed it right. Let's find out. 9.8199. Excellent. Find horizontal asymptote. So the horizontal asymptote is going to be choose the correct. Okay, so it's just going to be G equals 0. And the reason why it's 0 because the only variable you have is in the denominator, which is case 1. So the y value is 0. So that's the horizontal asymptote, right? Solve for G of h equals 0. So it's asking for the x-intercepts, but it doesn't have a solution because there's no variable up there. This is not possible. So it doesn't have a solution, okay? Well, that's it. Alrighty, so we're going to clear. And the last question, a standard form, sorry, a standard form of the rational function is there. They gave it to you. In r of x equals 2, okay, they give you another form of it. To write a rational function in standard form requires long division. Write this equation in standard form. Okay, so yeah, definitely. I think I'm almost certain I took it out of the homework, so I'm doing this for myself at this point. But we're going to go ahead and do this. We're going to do long division, 3x plus 5. And we're going to basically simplify this, so, or divide it out. So what do I multiply to x to get 3x? 3. 3 times x. We're going to distribute the 3 now. 3 times x is 3x. And 3 times negative 3 is negative 9. We're going to subtract. 3x minus 3x cancels out. 5 minus negative 9. So minus negative 9 is adding, right? So 5 plus 9 is 14. So the quotient 3 plus the remainder 14 divided by its original divisor. So there you go. That's all you have to do. So let's go ahead and write that out into the problem. 3 plus fraction, and then we're going to put 14 over x minus 3. Alrighty, and then choose the graph. So you can tell that this graph goes up and to the right. So let me clear this. Up and to the right. Let's see. Did it go? Oh, gotta get rid of this. All right. Up. Up how many times? Up 3 and to the right 3. So it looks. Oh, it must be. It must be in 2. So up 3 and right 3. A looks like it's the answer, but let's see. Oh, I see. The difference is the type of function. Okay, so remember, if the function is a positive function, it's going to look like this, b. A negative function is going to reflect over the x-axis. It's going to look like a. So we know it can't be a because it's the opposite. It's negative. So the answer has to be b. Why not d or c? Because it looks like it went left, and it's supposed to go right. So we know the answer is b. Oops. Vertical asymptote, x cannot equal to 3 because that's the denominator restriction. So that means that the vertical asymptote is x equals 3, right? X equals 3. So, and last but not least, horizontal. Remember I told you guys when it's in this form, this constant, that 3, is my horizontal. So y equals 3. Alrighty, let's see if this worked.